Let's look at the next two questions here, 6 and 7. Both of them are graphs that revolve around a specific axis. And so what we want to do is try and figure out what the volume is of both of these. And you don't see that instruction on here, but we want to find the volume of both problems here. And we want to find the volume by revolving question 6 around the y-axis and question 7, pretty sure it's around the x-axis. Okay. So when you're revolving around the y-axis, wow, I got a pinwheel going here. Let's see if I can write. Here we go. You're going to revolve this way. And so what that does is it creates a circular shape, because it doesn't matter at what point you're at on this curve. When you go around the y-axis, you get a circle. And then when you're here, if you go around the y-axis, you get a circle. And what we need to do is figure out the area of that circle. And if we can figure out what the area of that circle is and multiply it by the number of circles we can create, starting at 0 and going all the way up here to 5 pi over 4, we can get the volume of the area, the volume of that shape that we create. Well, the area of a circle is pi r squared. And if you'll notice on this problem, our radius is based off of where we're at in relationship to the y-axis. So our radius constantly changes from point to point to point to point all the way along the graph. And what we have to do is determine exactly what best represents our radius. And in this case, that is represented by the equation 2 tangent x equals 2 tangent of y over 5. That is our radius, because depending on where we're at, 2 tangent of y over 5 will tell us how far from the y-axis we are. So the integration for this part then actually becomes pretty easy. We stop integrating right here at this line, which is 5 pi over 4. It's our like upper boundary sort of thing. And we don't go past that. And we start at 0. So I'm going to integrate from 0 to 5 pi over 4. And the area is what I want to integrate. If you integrate area, you get volume. So that's going to be pi. That doesn't change. Pi is constant times my radius. 2 tangent y over 5 squared dy. Notice it's dy now instead of dx. All my variables need to match. My kids can use a calculator to help them with this. If you're not one of my kids and your professor or teacher has asked you to show all your work, then you need to do that. This isn't too difficult to integrate. Tangent would just need to be rewritten as sine over cosine, and then you'll have a little u substitution, which shouldn't be too bad at all. When you get done, if you're looking for that exact answer, the exact answer on this one would be 20 pi minus 5 pi squared. If you have to have an exact answer. Or if you punch this into your calculator and solve it out, you should get 13.484. So 484 is actually going to be 484. And both of these would be in units cubed. We weren't given specific units, but when you're talking about volume, that's what you're working with. The next question then has us rotating around the x-axis. That's what's in the instruction, which you don't see. So if we rotate around the x-axis, we're going to rotate this way. This line is not necessarily needed unless we're told to rotate around that line, but we're not. We're just said that, you know, these are our boundaries. So on this guy, what we're looking for is right in here. We're going to take this area right here and rotate it around the x-axis. And when we do that, we'll get a volume because we're going to create a 3D shape. So what do we do? Well, if I've got this point right here and I rotate it around the x-axis, it's going to sweep out a circle. And it doesn't matter where I move along this orange colored curve, I will get a circle when I rotate around the x-axis. So the question for us is, where do we start and stop? We start at 0, we stop at 5. So we're going to have an integral from 0 to 5. I get a circle shape just like I got on the previous problem, because as you rotate around a fixed point, it does create a circle. So I am going to work with a equals pi r squared. That's the area. And if you integrate area, you get volume. Well, how do I determine my radius? I just need to know how far from the axis of rotation, which in this case is the x-axis, how far from my axis of rotation to a point on the curve. How far from my axis of rotation to a point on the curve. How far from my axis of rotation to a point on the curve. And that is all being determined by this equation right here, the square root of 25 minus x squared. So plug it in. Pi times radius squared, square root of 25 minus x squared. This is actually going to be a really easy integration issue because we are squaring our square root, which makes this problem a lot easier to work with, okay? So once again, my kids can punch it in. You need to do what your teacher or professors asked you to do. The integration part is actually not going to be too difficult. The exact answer for this guy is going to be 250 over 3 pi units cubed. Or if you punch it into your calculator, 261.799. And both of those are going to be units cubed because we're dealing with volume. So both of these would be what's referred to as the disk method of finding a volume, which you get almost every time that you revolve some solid around an axis. The other two things that you could use are shells and washers, and we'll look at those next.